Hey, in this video I will be installing the SDL GPU library. SDL GPU is a replacement for SDL's rendering system, and it gives us a whole lot more power to be able to do really cool graphics. The SDL rendering system is fine for a lot of games, especially older kind of games, but for modern 2D games it's actually lacking some features that are important. Particularly shaders and certain shapes that you can render are missing, and the performance isn't very good. So to fix that, SDL GPU has a bunch of other features implemented and has some optimizations built in that make it so you can program the same way as you would, but it does so with much better performance when you're rendering lots of things on the screen. So I'm starting from my SDL base program with the image drawing that we had in a previous video, and I'm going to install SDL GPU and get this project set up and then converted to use it. So first of all, going to get SDL GPU. This website, this is the GitHub page for SDL GPU. You can get here by typing it in or Googling for SDL GPU or GitHub and SDL GPU. It'll bring you here, and what you want here is to go to one of the releases. There are 2 releases so far, and the latest unstable debug build is what we're going to be using, just because it'll always be there. So as of yet there's only one download for it, the Microsoft Visual C++ version. So download that because we're using Visual Studio. When that's done, bring it into your projects folder. So I have mine here. Paste it right in there, and then extract it. So the whole process is just like installing SDL itself. It's the same idea for every library that you install. So here it is. Now, just like when we installed SDL, it has a folder, and then it has a folder inside the folder, and I don't really want that. So I'm going to rename the uppermost folder so that I can move this out of there. So no more nested folder, and I can delete this empty one. So now I have just a single directory for SDL GPU. It has an include folder with all the headers in it, and it has a lib folder with the library files we need, the DLL here, and the lib file. So I'm going to take the DLL file, copy that, go up a couple directories, and I'll go into my project folder. SDL base is actually the solution folder, and in debug is where the executable gets put for my projects here. And I have my SDL2 DLL already here, so I want my SDL2 GPU DLL in the same place. So now it's all set up, the directories are all set up, and I need to set up my project to point to those directories. So back in Visual Studio with the SDL base project with image rendering, right-click on your project, go to Properties, and in the linker category, expand that and go to Input. We'll have to add SDL2GPU.lib to this list. SDL2GPU.lib. Okay. And then in VC++ directories, you can see this project still has those absolute paths that have the C C drive in it. So I'll just do the same thing, or maybe replace it. But in include directories, we'll be editing this. And if I remember correctly, it was solution_dir ... So I'm going to do the same thing for SDL2 GPU. First I'm going to make sure I get the directory right. So I'm going to find that directory, include, and I'm going to change this so that it uses the solution_dir macro. There we go. Copy that and use it in the library directories. So in library directories, we want to point to the SDL GPU directory /lib. And then I'll just fix this up while I'm at it. There. That looks good. And press OK. That should be all we need to link up with it. So at this point it should build just fine and link with SDL2 GPU. So we're ready to write some code. SDLGPU.h actually has its own include for SDL.h, so you can delete the include SDL.h and it won't hurt anything. It already pulls it in like that. And so this is just fine. And I'm going to start off in main. In main, we first of all initialize SDL and we create a window. So in main, SDL init is called to initialize SDL, and then a window is created, and then a renderer is created. So since SDL GPU replaces our rendering system here, we're going to pretty much be replacing everything that has to do with drawing things to the screen. So even with SDL init, SDL GPU will do that for you if you want it to. So we can even delete this part. So let's delete SDL init. And the window we were creating with 800 pixels by 600 pixels. And that's really the important part of it. The rest of this is just details. And SDL GPU also sets up the window when it initializes. So we'll just tell it what size to use once we're at that point. And then the renderer, we don't need at all. But the equivalent concept in SDL GPU is the GPU target. So I'm making a GPU target star that's going to point to a target that I'm calling the screen. And so conceptually it's a lot simpler to say that we're drawing to the screen and the drawing calls are acting on the screen than it is to talk about using a renderer. So set this equal to GPU init, and GPU init takes 1, 2, 3 parameters. Width, which was 800 for the window, and 600 for the height. And then SDL flags, we weren't passing any flags in, so we don't really need any. You can put 0, or you can put GPU default init flags, which is technically the same thing as 0, but when you're reading through this, it makes it clear that this is where flags would go and we're not using any. So GPU init initializes SDL, initializes SDL GPU, and creates a window for us. So we don't need this renderer line anymore, but we still want to check to see if the screen is null. When the screen is null, that means it's not pointing to any object, and we had an error. So I'm just going to leave that so we quit the program if there was an error. Now when SDL loads images, it's a two-step process. You first load the image into memory, into your RAM, from the file on disk, and then you create a texture from it so that you can actually render it to the screen. In SDL GPU, that's done in one step, and we create a GPU image, and I'm going to call it image, and set that to GPU load image. And GPU load image does essentially both of these steps together. You can call it with your same, I have smiley.bump, just a bitmap of a smiley face, and you can delete that too. So GPU load image will load the image from the file and get it ready for us. And I should check to make sure that the image isn't null. So if the image is null, I'm just going to return 4. You could have an error message saying that the image failed to load, so I'm going to add one of those too. There are a bunch of ways to print out to the console. We've used cout before. There's also printf is a common one. SDL even has its own logging function, and SDL GPU has its own logging functions too. They all have just slightly different semantics about them. But I'm going to use the SDL GPU GPU log error. So that specifies that an error has occurred, and this is the message that should be printed. On certain platforms like Android, they have different logging levels for errors and warnings and information, and so this can be presented to the developer in different ways. So, image failed to load. So this function takes a string, and it can also be formatted like printf and have variables, but I'm not using any right now. And this \n is a new line character, so that just ends the line and goes to the next line when it prints. So this stuff down here doesn't have anything to do with graphics. This is just the loop information here, and then we have event handling, which should all stay the same. The way we update the simulation should stay the same as well. Now when we get to drawing, that's when everything changes. So here we set the color that SDL is going to draw with, and then we use SDL render clear in order to clear the screen. Well, in SDL GPU, this is GPU clear, and that'll clear the background to black. If we want to specify what color, use clear RGBA. We want to pass in the target that will be cleared, which is the screen, and we're going to give it the color. We used green last time, opaque green. So now you can delete this call, and that does it all in one line. Next is drawing the image. Draw image took an SDL renderer and an SDL texture. So the equivalent is to send, instead of the renderer, the screen target, and the image is not a texture anymore, it's a GPU image. And so up where we declared this function, we'll need to fix it up so it does this. So the renderer replaced by a target called screen, and texture replaced by the GPU image. So in this function, we are checking to see what the width and height are of the image, and then we're using that to render it to the screen. In SDL GPU, to render to the screen, you'll use GPU blit, which is an old kind of computer graphics term, blit, to mean copying regions of pixels from like one image surface to another. So GPU takes the image, GPU blit takes the image, the source rectangle, just like SDL render copy. We weren't using any source rectangle, just the whole image, so null. And then the target screen, that's where it's going. And then the X and Y coordinate. So we can put X and Y there. And so that pretty much gets rid of all of this. The width and the height are stored as part of the image, and SDL GPU actually has a little bit different semantics than SDL renderer here, and this is really important to note. That SDL GPU draws images at their center. What that means is we have to treat these coordinates, if we want to draw at the exact same place as this was, we have to treat these coordinates as the center position, which means if we want the same rendering, we have to shift these by half of the image dimensions. So I'm going to subtract image, and then I'm going to use an arrow, because image is actually a pointer to an object. This arrow, minus and then greater than sign, this arrow dereferences the pointer, so it gets to the object that we're pointing at, which is the GPU image, and then accesses one of the variables stored in that object. So we're going to use W for width, and then over here subtract the image height divided by 2. So that should replace all of that. And you'll notice that draw image and this GPU blit call are now very similar. Screen is passed here, image is passed here, and just an X and Y coordinate. So draw image now doesn't give us that much advantage typing wise over just calling GPU blit. So it's up to you if you want to just use GPU blit directly or create your own image rendering function like this. Either way is fine. Now when we go on back down to where we left off, we are checking the dimensions of the image again down here, and then drawing the image so that it's shifted so that it fits onto the right lower right corner of the screen. So to do that with SDL GPU, well, we would use essentially the same code. Since we're using draw image here, I'll just change this to screen, image, and then shifted by the image dimensions. So instead of making new variables and asking for the image dimensions, I can delete those and instead use image arrow W and image arrow H. So that should work as expected. And then SDL render present sends the completed frame to the screen, and this is replaced by GPU flip, which is another old way of talking about sending graphics to the screen. So that takes the screen just like render present takes the renderer. So that replaces that. And then when we're done, we are freeing the texture file, or texture data, and to do that with SDL GPU, use GPU free image. And then at the end of it all, change SDL quit to GPU quit, and that'll take care of all the cleanup for SDL GPU. So that's it. That's all of the code change and the library all linked up. So when we build it and run it, it should work just the same way. Now another thing to note, GPU load image actually loads any sort of image format. Well, the normal ones, not any of them, but bitmaps and PNGs and JPGs and all of that. So here we have the smiley image rendered. So this doesn't look like what I expected, so I think I made a mistake somewhere. This is rendering it at a different location, and there should be two of them. So I'm going to close this, and I see my problem right up here. In draw image, I was shifting them back, so this would actually draw in the wrong place. This should be shifted forward. I'm used to doing it the other way, but this should shift it so that it draws just like SDL renderer does. Let's try that again. There we go. That's what I'm expecting. So one in the upper left corner, one in the lower right corner. There. And that's all there is to it. This is all of the basic stuff of SDL GPU. There's a lot more we can do, and we haven't even rendered any shapes yet. So we'll do that, and I'll leave you with rendering a rectangle. So down in the draw region over here, after I draw all these images, I'm just going to add a new line. This is a function called to GPU rectangle, and I'm going to fill it into GPU rectangle filled. If you check out the documentation for SDL GPU, there are a bunch of different shapes. And I'm going to just make a filled rectangle. Pass it the screen, it takes a target, and then it takes X, Y, and then another X and Y, and then a color, SDL color. So these X and Y pairs are the coordinates of the top left corner and the bottom right corner. They define a rectangle. So if I wanted to draw a rectangle, say starting at the upper left hand corner and then extending down, extending across 60 pixels and down 30 pixels. That's what I would put. And then the color. I could make a variable out here, an SDL color variable, and set it up with the color I want. But I'm going to use a different SDL GPU function so that I can put it right here. GPU make color lets me type in my color values right away. So I'm going to make a red on green background will look weird. So I'm actually going to make a yellow rectangle. There we go. And you can even make it slightly transparent, see-through, by changing this value. I'm going to go ahead and do that. I'll make it 100. So it'll only be a little bit yellow overlaid on top of part of the image that I have drawn. So trying this out, see what we get. There we go. So there's my little yellow rectangle in the corner. Not full yellow because it's a little bit transparent. You can see through it. So that's it for now. See you later.